Okay. All right. So, Feroz, what we are going to discuss today is Amazon Web Services. We are actually going to talk about cloud computing in general. Once we are done with cloud computing in general, then we are going to dive into what Amazon Web Services really are. So, as part of cloud computing concepts, we are actually going to discuss 4 W's. We are actually going to discuss what cloud computing is, when do we need to use cloud computing as a solution, why do we need to use cloud computing, and then who is responsible for security and compliance within cloud computing environment. So I'll go to the next slide, and this slide is actually setting an agenda for the demo today. This is what we are going to discuss in the demo today. We are going to discuss what cloud computing is, what are the different deployment models when it comes to cloud computing, and what are service level agreements. Now, service level agreements are important because they are actually tied to deployment models, different deployment models. Then we are going to discuss when do we need to use different service models when it comes to cloud computing, because there are different service models for cloud computing. When do we need to use horizontal scaling, and when we are going to use vertical scaling. We are going to discuss that. And then there are different costing models. So we are going to segregate between different costing models and going to understand when we are going to subscribe for which kind of costing model. Later on, we are going to discuss why do we need cloud computing, because that is very important and very relevant to this topic. And then in the end, we are going to discuss who is responsible for security and compliance when it comes to cloud computing. So moving on to the next slide, where we are going to discuss what cloud computing is. Now, what you are seeing on the screen right now is the definition which comes from National Institute of Standards and Technology. So what cloud computing really is, cloud computing is any environment which can be provisioned on demand to have network access to a shared pool of resources. Now, when I'm saying shared pool of resources, they can be servers, they can be storage, that can also be an application, and can also be an integration of all that together as part of a service offering. Now, these resources should be able to rapidly provision and should be able to release to the end user with minimal management effort or service provider interaction. So any environment which actually fulfill all these requirements can be called as a cloud computing environment. Then on top of this definition, there are essential characteristics which define what cloud computing environment should actually be. So one of the most important characteristics of a cloud computing environment is on-demand self-service. What that simply means is an end user who is looking for provisioning resources in cloud should be able to do that task. Him or herself should not have to interact with a regular server engineer to provision servers, should not have to interact with the regular database administrators to provision database. And he or she should be able to do it, him or herself. Other than that, a cloud computing environment is going to provide broad network access. So an application, for example, an application which is provisioned in a cloud environment should be accessible over the network through any kind of endpoint. It can be a desktop, it can be a laptop, it can also be a mobile or a tablet. Then there is a resource pooling. Now, resource pooling is what happens is in a cloud environment, a physical server actually has an virtualization layer on top of that, and that virtualization layer is sitting beneath an orchestration layer. Using this concept, a cloud provider is able to use the same physical hardware and carve that out for multiple clients in a multi-tenant environment. So any environment which is able to provide that resource pooling can be called a cloud computing environment. So this is one of the essential characteristics which actually defines a cloud computing environment. Next point is rapid elasticity. Now this comes in line with what cloud computing should actually be. The concept of cloud computing is that it should be able to respond to the demand. So if the demand of a particular website, or if the demand around a particular product is increasing, the cloud environment should be able to scale up on its own. And if the demand is decreasing, then the cloud environment should be able to go down again on its own. So in summary, the cloud environment should be able to respond to the demand of that particular resource. And then the last essential characteristic of any cloud computing environment is measured service, that there should be an automatic control of metering capability of the resources which are used in cloud computing environment. So there should be an automatic control and reports around how much storage is being provisioned to client A, how much compute is provisioned to client B. So any environment which is able to suffice all these characteristics can be called a cloud computing environment. Now, moving to the next section, we are actually going to discuss what are the different types, or what are the different models, deployment models when it comes to cloud computing. So there are 4 different deployment models which are known to us so far, and because it is an ever-changing and rapidly changing technology, so in future you may come across a different kind of deployment model, but so far there are 4 different deployment models. The first one is public cloud. Now public cloud, the definition of a public cloud is that it is provisioned for general public use and is hosted by a service provider. It is best suited for variable workloads, for test and dev environments, and also for environments where you need disaster recovery capability. It offers the lowest cost of ownership and has rapid elasticity and flexibility, and the deployment time is really fast. The challenge or the risk of a public cloud environment is data security and privacy, even though in subsequent slides we are going to learn that the data security and privacy piece is a customer responsibility. So the public cloud provider is not directly responsible for it. So we are going to discuss that. How can we overcome this challenge? And then service availability. Now again, that challenge is probably not true, because of the fact that a service availability is defined by how a customer is designing the environment in a public cloud. So we can again overcome that challenge, and I'm going to describe that when it comes to AWS designs. Private cloud. Private cloud, this I think has been around for a very long time, and all of us and most of us are actually used to private clouds. So private clouds is a data center hosted for a single organization, and in a private cloud, virtualization on a physical server or on a physical hardware is still there. But what happens is that generally what happens is that the private clouds are actually dedicated to a single client or single organization. Now there can be segregation when it comes to different line of businesses, but all those different line of businesses are actually reporting to the same mothership. So so in a private cloud there is still virtualization, but that is actually dedicated to a single organization. It is best suited for environments where we are going to host sensitive data, or where we are responsible for maintaining certain sort of compliance. It offers greater security and control. And we also have higher customizability ability in the environment, where the environment can be customized for that particular client requirements. Because in public cloud, it is a multi-tenant environment. So it cannot be customized to a single customer need, whereas in private cloud, it can actually be customized to a particular client. Now, the challenge of a private cloud environment is high cost of ownership, because it is dedicated to a single client. So the cost of maintaining that environment is charged back to a single client. And it requires in-house skill set to maintain a private cloud environment. So that is again an investment in human resources. Moving now to third deployment model, which is community cloud. Now, community cloud is not a public cloud. It is actually maintained and owned by a single community, which can either be a hospital, can also be a group of colleges, and they maintain and host their resources within the community cloud, and those resources are only accessible by that community and can also be made accessible over the internet. But in general use case, what happens is that the resources hosted in community cloud are being accessed by the end users who belong to that community. Now, as I mentioned, that the use case for a community cloud is within hospitals, clinics, and universities. The cost of ownership, the total cost of ownership for community cloud is actually less than private cloud, but is actually more than public cloud. The challenge is complex IT governance. Now, what happens is in a community cloud, because there are different people involved and there are different organizations involved, which may not follow a single set of standards. So some of them may follow ITIL for their environment and some of them may not, right? So it becomes very difficult to govern a community cloud environment. And again, for maintaining a community cloud environment, there needs to be an investment made in human resources. Now, moving to the next and last deployment model, which is hybrid cloud. Hybrid cloud is actually a combination of public and private cloud. In the existing environment, in the existing IT environment, hybrid cloud are the most used cloud deployment models. Most of the clients are using public cloud for their test and development environment, and also for less critical production workloads, whereas high critical or most critical workloads are still being hosted within the data center, which is the private cloud. Now, it is best suited for real case scenarios. It is actually best suited for enterprise clients. It offers lower TCO, but again, the total cost of ownership is actually more than public cloud, but is actually less than private cloud. The challenges, one of the significant challenges of running in hybrid cloud is interoperability. Now, what happens is, for example, if you are running VMware as a virtualization in your data center, and your data center is actually connected to Amazon Web Services. Now, Amazon Web Services do not understand native VMware language because they are using Citrix Zen servers. They are not using VMware for their virtualization. So sometimes the interoperability between on-premise data center and public cloud environment can become challenged, but again, that challenge can be overcome by configuring resources in the right manner, and then replicating data to public cloud to make optimal use of resources in public cloud. Moving to the next slide, this is the last part of what slides. So this is the last definition, which is about service level agreements. Now, what are service level agreements? And this is very important to understand, because when we are going to discuss different service models about cloud computing, now service level agreements will become important. So before we get into that, we should be able to understand what service level agreements are, and we should have clear understanding on what service level agreement really is. So SLA, that is the short form for service level agreements. SLA is a negotiated agreement between two or more parties designed to create a common understanding about a service or multiple services which can serve. So an SLA can serve either as a communication tool or a conflict resolution tool or service effectiveness tool, a guide to measure service effectiveness. Now, there are two main components to any service level agreement. One is service elements, and the second one is management elements. Service elements in a service level agreement actually defines what's of that agreement. So what kind of services are being provided, what condition will, what are the conditions of service availability, what are the service standards, and what are the responsibilities of parties involved. And then there is second piece, which is management elements. Now, management elements actually define house of the service level agreements. So how the track service effectiveness will be measured, how information will be reported and addressed, how disagreements will be resolved, and how we are going to review and revise any service level agreement. So that's what the service level agreement is. Now, I'm going to move to the next slide. In this particular slide, we are going to discuss when do we need to use cloud computing. Now, on the screen, what I have right now is a pizza preparation example. And using this pizza preparation example, I'm going to lay down different service models when it comes to cloud computing. So think about it. When you are preparing pizza at your home, what happens is the kitchen, oven in the kitchen, pan in the kitchen, and the ingredients to prepare pizza, all that belongs to you. That particular environment, your house, when you are preparing pizza within your house, that is your traditional on-premise service model. Now, moving on to the next example. So let's say you go to a place and you rent a house. Now, in that rented house, can you hear me okay now, Feroz?
Yeah.
Okay. Okay. Okay, so going to the next example. So let's say you go to a house and you rent that house. So what happens in that rented house is that the kitchen, the oven, the pan, that may not belong to you, because that is being owned by the owner of that particular house. But then the ingredients to prepare a pizza, that will have to come from you. So you may go to a grocery store, you procure those items, you come back to your rented place and you prepare pizza for yourself. So that is infrastructure as a service. Now, let's talk about third example where, let's say you go to a relative's place or you go to a party where people are waiting for your expertise when it comes to pizza preparation. So you go to that place and they already have they already have their own kitchen, they already have their oven, pan, and they also brought ingredients for you, because what they need from you is your experience and your expertise to prepare pizza for them. So that is platform as a service. And the last example is you go to a restaurant or you go to a hotel, you go to a place where you can go and eat pizza. So they bring pizza to you, you pay them for that, and you eat that pizza and you leave. So that is software as a service. Now we are going to map this example with cloud computing service models, and that's what this looks like. When it comes to on-premises cloud or private cloud, what happens is that you are responsible for the whole stack. You are responsible for maintaining networking, storage, servers, virtualization, operating systems, and up to application, everything falls under your management domain. Whereas when we talk about infrastructure as a service, what happens is that the infrastructure as a service provider is going to provide you infrastructure up to virtualization there. But after that, everything else becomes your responsibility. Then there is platform as a service. Now, platform as a service, providers are going to provide you a platform on top of which you can develop your own application, provide your own data, and create your own version or your own flavor of a particular application stack. And then the last piece is software as a service, where you actually subscribe for a software which has already been developed, managed, and hosted by a provider, and you end up paying a monthly subscription fee for utilizing that application. Next slide is about costing models. So once you get an understanding on different costing models, you would be able to actually figure out when do you want to use which kind of costing model and what is going to make sense in a particular scenario. So what I'm going to describe here is there are different service models, right, as we discussed on the last slide. So there are different pricing structures for different service models. So let's start with infrastructure as a service. When it comes to infrastructure as a service, there is a certain dollar value for the amount of compute or for the amount of storage you are using, and that dollar value is calculated on per hour basis. So even if you utilize a component only for 10 minutes, you will still be paying to the provider for that complete hour. So that kind of pricing is actually known as on-demand pricing, where you actually spin up resources based on the demand, and the environment responds to that demand, whether it is going up or whether it is going down, and you actually pay for that resource. Then there is another concept which is long-term commitment. So if you know that you need certain number of compute resources or you need certain amount of storage for a longer period of time, so you can reserve that capacity. And once you reserve that capacity in an infrastructure as a service provider environment, you get lower rates and you get certain discount, which actually drives your total cost of ownership even lower, and you get better pricing. Then there is another component to costing when it comes to infrastructure as a service providers, which is the amount of data which is being pulled into and pulled out of the environment. Now that is calculated in gigabytes, and there is a certain charge for the amount of data which you pull in or pull out of the environment. And the last piece of this costing is the price per put, copy, post, or list request. So there is a certain price for the amount of requests you are going to put on the storage or copy from that storage. So all that combined is going to give you the overall pricing for an infrastructure as a service solution. Now let's talk about platform as a service. Now platform as a service, as we discussed on the last slide, that a platform as a service provider is going to give you the platform on top of which you actually deploy your application, you put your own data, and you create your own usable stack of that application. So the pricing is determined by price per user. Now that is charge per month. The amount of storage, additional storage you need in that environment, if you need that, because in some cases the default allocated storage actually works, but in most of the cases you subscribe for additional storage. So there is a charge, allocated charge to that. Then again, there is a data transfer charge. So the amount of data being pulled in or pulled out of the environment, there is a charge to that. And then there is a charge to the API code which you wrote in that environment, and the amount of queries being done to that API. API stands for Application Programming Interface. So the kind of code you have written, and if there are queries to that code, then there is charge to that as well. And then the last piece is software as a service. As we discussed on the last slide, software as a service, what happens is we subscribe for a software which is already being developed and managed by the provider. So we are only responsible, or we are only paying for using that service. We are not responsible for maintaining, managing, or creating backups. So the costing model for such services is actually very simple. What happens is that you pay on per month basis for the amount of licenses you are using, or you can also get into a long-term commitment with them and bring your cost down. So these are different kind of costing models. Now, moving to the next slide, what we are going to discuss is different kind of scalings. So there are two kind of scalings, and it is important to understand them so that you know in which particular scenario you are going to use which kind of scaling. So one is the horizontal scaling. Horizontal scaling is basically what happens is you add more servers, or you add more hosts into the environment to respond to the demand. That is horizontal scaling. Whereas vertical scaling, what happens is that you add compute resources, for example, RAM or CPUs, to the same server to make it bigger, to make it faster, so that it can respond to increasing demand. Now, both of these scenarios are actually relevant. They are relevant in cloud computing. It depends upon what kind of workload you are running and what is the requirement for that application. So it depends upon the type of workload you are running. That is going to determine the kind of scaling you need in cloud computing. Moving on to the next section, which is why do we need cloud, right? This is a very important question and needs to be answered before we actually get into AWS. We all understand that there is a very high demand when it comes to cloud computing right now. And there are reasons to that. There are factors to that. So I'm going to, on a very high level, I'm going to touch base on each one of them and going to make it very clear to you guys that if cloud computing is in so much demand, then there is a valid reason, there is a valid logic behind that. So as you can see on the screen, there are multiple reasons. There are multiple benefits to subscribe for a cloud computing environment. Cloud computing is actually location independent. So when it comes to AWS, there are multiple data centers, there are multiple regions, and a workload or an application can be provisioned in a different country, and users can actually access that particular workload in a different continent altogether. So it is location independent. There is a scalability and sustainability, as I was talking about, that cloud computing responds to increase in demand and decrease in demand. There is 24/7 support available, but again, you have to subscribe for that. There is an additional cost associated to it, but once you subscribe for that, you actually get 24/7 support. Agile deployment. Agile deployment is actually an outcome of the fact that there is an orchestration layer in between, and what happens is the person who is in requirement of a certain workload can actually provision that workload for him or herself without even have to contact to a data center engineer. Cloud computing, the whole concept is running on virtualization, on the multi-tenant virtualization, and that's why the cost is so low. Pay as you go, this is absolutely correct. This is again is tied back to the on-demand pricing, as we discussed on the last slide, that you only pay for what you are using in the environment, and once the demand decreases and the environment scales down, you actually don't pay for the resources which were spun up when the demand was on its peak. Then there is utility-based time-sharing models. So there is a concept, there is a costing concept, which is, let's say there are 100 clients and they have spun up different workloads. So and in that particular scenario, let's say if there is a capacity which is left out, so you can subscribe for that capacity for a very low amount and use that capacity. But again, there is no guarantee for that available amount of capacity to be available for you all the time. So that kind of compute is good for environments where you are doing some sort of analysis which is not production impacting. So let's say you are doing some sort of analysis which is not going to impact your production, and you need a temporary compute. So you can subscribe for that utility-based time-sharing models. As I discussed earlier, there is a lower total cost of ownership, and that is because the environment is running on a multi-tenant logic. So multiple clients are using the same physical hardware, same virtualization layer. So that's why the cost is being divided among multiple clients. Secure storage and management. So if you remember that in one of the slides, we discussed that there is a challenge when it comes to public cloud computing, which is around security. But as you can see that there is a benefit when it comes to secure storage and management, and how a challenge, how a statement which was actually a challenge in earlier slides now has become a benefit, right? So I'm going to describe this. I'm going to describe how a challenge actually becomes a benefit. I'm going to talk about it when we are going to discuss Amazon Web Services in particular. I'm going to discuss that how the security actually is a responsibility of a client. So a client can configure their environment and make it secure enough so that they get their compliances met. They get their peace of mind that even though the data is in public cloud and is actually outside the perimeter of data center, of the private data center, but they are still getting maximum security for their data. Moving to the next slide, this is where we are going to discuss the benefit. This is another benefit of a cloud computing, and this is actually very important benefit, and this is a real-time example. So when anyone who is selling Amazon Web Services to the client, most of the time they actually bring this graph up because this graph actually describes the cloud economics. What happens is on the graph, what you are seeing right now is that there is a blue line, right? That blue line is okay. So before we get into that, actually, I should make you guys understand that on the x-axis, what you are looking at is actually time, and then on the y-axis, what you are looking at is the infrastructure cost or the investment made in infrastructure. So there is a blue line, right? So that blue line is describing traditional environment, traditional hardware environment. So think about days when people were maintaining their own data centers, right? So what used to happen? There used to be a capital expenditure in procuring large enough servers and doing some sort of capacity management or capacity calculation for a period of time, and then invest in large enough servers so that the requirement for subsequent years or for coming years can be met, right? So let's say once they hit that particular time frame, so let's say a server was bought considering 2 years expansion, right? Now at the end of the second year, they'll again, the same study needs to be done, and then the environment needs to be expanded further to let's say to respond to 5 years demand, right? So at the end of the fifth year, again, that exercise will have to be done, right? So that's why you see that blue line is actually growing, but then it remains constant for a period of time, because every time when we are going to jump to the next level on the blue line, there is a capital expenditure which needs to be made. Now, the red line is describing customer demand. So that's the actual demand, right? So we, in a traditional environment, we are constantly investing in the capital, in the hardware. We are constantly putting investment into the hardware. But at one point in time, what happens is that the capacity planning which was done in the last exercise actually wasn't correct, or probably the product which we are selling or the product which we are advertising over the internet has become very popular, right? So the customer demand actually increases. So there is a gap period, where we don't have enough hardware in our environment to respond to that demand, and we lose our clients. We lose those requests. They don't come to our environment because there is a physical limitation. So what we do is we again try to ramp up our hardware and get to the next level, right? But who knows, what if our application team comes up with another idea and they make some changes on our website, and that website again becomes very hit, right? We'll again have to do that exercise. So that is the traditional environment. Now, how cloud helps us in that, right? This is the biggest sale point when it comes to cloud, is that the cloud capacity is actually elastic in nature. You are paying for what you are using. You are not making any sort of capital investment when it comes to cloud. So you subscribe for a resource. You subscribe for, let's say, minimal compute resources to start your website, and eventually your website becomes a big hit. So you can configure the environment in a way where it will be able to automatically respond to the requirement, where it will be automatically able to scale up or scale down based on the demand. So this is very important to understand. This is the biggest benefit, in my opinion, when it comes to cloud, that a cloud can actually respond in real time to increase or decrease in demand. Okay, moving on to the last section of this demo, what we are going to discuss here are two pieces. One is security, the other one is compliance, right? So security happens to be the major concern when it comes to cloud computing, right? Everyone is actually worried, and they should be, right? It's their data, and they should be worried that what will happen to their data when it goes out of their environment and it goes to a public cloud, which is actually using a multi-tenant logic, right? So my data is sitting on the same hard drive, or is sitting on probably the same physical hardware, where a lot of other clients are sharing that hardware, right? So what if they start reading my data, right? So that will be a data breach. Okay, so there is a very clear concept when it comes to security in cloud computing, that security is actually a shared responsibility in any public cloud environment, right? We are talking about Amazon Web Services. That's why on the slide deck you see Amazon Web Services example, but this actually holds true for any cloud computing environment, for any infrastructure as a service cloud computing environment, I should say. So what happens is, when it comes to Amazon Web Services is responsible for securing their facility. They are responsible for physical security of that facility, right? But how about securing operating system? How about securing your application, right? So all that falls in customer responsibility domain. So customer is responsible for writing their application in such a way that it is secure enough that unwanted elements do not gain access to it. Similarly, customers are responsible for configuring their operating system secure enough so that the unwanted elements don't gain access to it. So security happens to be a shared responsibility in cloud computing environment. And if configured right, if configured as per best practices, and again, we are going to discuss security in detail because security happens to be the biggest topic when it comes to Amazon Web Services. So when we are going to discuss Amazon Web Services, there will be a dedicated session for security. So when we are going to discuss security in Amazon Web Services, what we are going to actually realize that security, if configured right, Amazon Web Services can become a very secured environment. But if not configured right, then it will become vulnerable, and that holds true even to your private cloud environment, right? If you are not configuring, if you are not following best practices, if you are not containing your resources in a secured manner, then it will be vulnerable, be it on cloud or be it on the private data center. So security is a shared responsibility. There are pieces for which Amazon Web Services is responsible, and then there are pieces for which customer is responsible. Moving on to the next slide now, this slide actually gives you an idea when it comes to Amazon Web Services. As I mentioned earlier, we are going to discuss it in detail, but this is to give you a high level overview that there are different layers where the security can be implemented before traffic reaches the data, before traffic reaches the customer data, right? So there are route tables. Route tables are configurable in AWS environment. Route tables can be configured. So that is one place where the security can be implemented on a network layer. Then there are access control lists. Now access control lists actually sit outside of subnetworks. So again, all this you need not to worry. Don't make notes. Don't worry about the jargons which I am using right now, because we are actually going to deep dive in each one of them. What I'm trying to showcase on this slide is that there are multiple layers where the security can be configured when it comes to public cloud, when it comes to cloud computing. And as I mentioned in the last slide, if configured right, the environment in public cloud can become very secure and will only allow access to the elements which customer wants access to their data, right? So don't worry about jargons. We are going to discuss all this when it comes to Amazon Web Services network configuration. Okay, this is the last slide for this demo. What we are discussing here is compliances. So because we are talking about Amazon Web Services, so we are talking about compliances or certifications which Amazon Web Services has. So Amazon Web Services is SOC compliant, is actually ISO 27001 compliant. It has PCI compliance as well, which actually holds true for finance and banking industry. Then there is FedRAMP and GovCloud. So AWS has dedicated government clouds, which is hosting workloads for governments. So there is a dedicated section when it comes to AWS, and it is compliant to host government resources. Now, Customers who have deployed their workloads or their applications, they were able to successfully gain HIPAA compliance. They were able to successfully gain FISMA compliance, and all that was done based on the configuration achieved, or based on the configuration elements in AWS done by a client. So going back to our slide number 1, where we started from, this is the recap. So after this demo session, I hope that you would be able to answer what cloud computing is, what are the different deployment models of cloud computing, what is SLA, and this is important because when we are going to discuss AWS services, different services, there are SLAs attached to each one of them, and we are going to discuss that. I hope by now you guys understand the different service models. This is where we actually discussed an example to prepare a pizza. So that's what service models are. Then there are two different kind of scalings, horizontal versus vertical. There are different costing models depending upon the service model you are using in cloud computing. We discussed benefits of cloud computing, where we actually looked at the graph, time versus investment, and we looked at how a cloud computing environment responds to increase or decrease in demand, and we never lose any request or any incoming request for any of our clients. And at last, we also looked at security and compliance. So as I discussed, that security, if configured correctly, AWS environment can become really secure. And then in the end, we actually looked at the kind of certifications or the type of certifications which AWS has, and the kind of compliances which customers were able to achieve using AWS. So that's pretty much it for this demo session. If you guys have any question, Feroz, if you have any question, please go ahead and ask.